variety of different ways to represent concentration units, but one of the biggest ones is the idea of very trace, minuscule, minute amounts. And it's usually some kind of environmental question or something where they say, you know, so-and-so dropped this much toxin into a pond, you know, if fish survive at this and whatever, will the fish be affected, right? And so you're looking at a very, very small amount, which is why we use something called ppm. ppm stands for parts per million. And what that means, okay, is that if you had 1 million parts, that minute amount would be a small little smidge of that 1 million. Okay, ppm, let's say something has a concentration of 48 ppm. Okay, let's say we're saying 48 ppm of whatever substance. What we actually mean there, so if I say that I have a concentration of 48 ppm or parts per million, that means of my total 1 million units of that substance, 48 of that 1 million will be whatever this is. Okay? This is where our equivalencies come into play. Because 1 ppm is the same thing as saying if you had 1 gram out of 1 million grams. Okay? So 48 ppm would be 48 grams over 1 million grams. Okay? Now, if I see the word gram in gram, what do grams measure? Do they measure solids or liquids? Grams measure solids, right? Milliliters and liters measure liquids. So if you're saying, if the situation was something like, you know, you have a soil sample. Soil is a solid. Dirt is a solid. So you're going to have the solid equivalencies. You need to remember these equivalencies. Okay? Saying this, saying 1 gram in 1 million grams is exactly the same thing as saying, okay, 1 milligram in 1,000 grams or 1 milligram in 1 kilogram. Okay, how many grams go in a kilogram? 1,000. And if I divide 1 gram here by 1,000, there are 1,000 milligrams in 1 gram. So if I divide this 1 gram by 1,000, I get 1,000 milligrams, right? So if I'm making this guy 1,000 times smaller from here to here, I must also make this guy 1,000 times smaller from there to there. That's what this means. That's why these are equal. They're the exact same thing. It's only, instead of having 1,000 pieces of cake, like 1 million pieces of cake, okay, let's say you had 1 million pieces of cake and only 48 of that million were chocolate cake. The rest were vanilla. Okay, that would be the same thing as saying, okay, you've got 48 ppm of chocolate cake in a sea of 1 million pieces of cake. All right? But that's the same equivalency as saying, okay, basically you divide this guy by 1,000, you get this. You divide this guy by 1,000, you get rid of 3 of these, you get this. That's where these come from. So when you look at whatever word problem you are given, if you are given something in milligrams or grams over, like if it's a solid, if it's in an amount of soil or whatever, okay, and a mixture of some sort, I don't even know what example they would use. Most often it has to do with soil and toxins in the soil. they're going to use grams on the bottom. If, on the other hand, it is a liquid, okay, if, on the other hand, it's a substance in a liquid, this changes a little. 1 ppm of substance in a liquid is going to be a little bit different. So 1 ppm here is equal to 1 gram of substance over 1,000 liters. Now, in this case, we're using liters because it's a liquid. It's some kind of substance in an amount of liquid. And if the question is given to you and it says, Taylor was feeding her fish and she accidentally dropped, acetone nail polish remover she accidentally dropped 3 grams of acetone in her fish tank. Okay, will her fish survive if they can only tolerate this amount? Girls. So if somebody says that, they're dealing with grams in an amount of liquid, if you read that and you see that the small amount of ppm is in grams, then you know that you've got to use this breakdown. Because then we get 1 milligram is equal to what?
1 liter.
Okay, 1 liter. Now, are there any other equivalencies for this?
Well, there's 0.001 grams over 1 liter.
Yeah, and that's the same thing, because this 1 milligram, there are 1,000 milligrams in 1 gram. So that's the same thing as saying 0.001 gram over, 1 liter. That's the exact same thing. 1 milligram, personally, I like dealing with milligrams than with decimal grams. Okay, I like the whole number aspect. I get less confused with whole numbers. If you know the equivalencies, you should be able to do ppm. Okay? Let's look at a different way of telling you this. And on page 53, is it? There's at the top of the page in your text, there are a bunch of bullets on different ways to, make concentration units. Look those over. Okay? Because I wouldn't put it past them to talk about, the grams per liter, which is general concentration. ppm is another form of concentration. It's pretty much going to be a ppm question because, that's the math. And all it is, girls, 90% of this problem is decoding and finding the right equivalency. The other 10% is, you've got, if it says you've got, 30 grams, all right, 30 grams of whatever fell into a pool that has 4,000 liters in it. Grams and liters, you go back, you find that equivalency. If I've got 30 grams of substance in 4,000 liters of solution, how many ppm is that in 1,000 liters? Because I know back here that 1 ppm is going to be equal to 1 gram over 1,000 liters. But here, what's the equivalency of 30 grams in 4,000 liters? How would you solve something like this? You cross multiply. This is not a mathematically hard problem. Okay? You just have to be able to decode them. Please look at your test on chapter 2 because I gave you several, and look at your practice. There's a practice problem sheet on the portal. Some of you might still have it in your notes on ppm.